everyone. My name is Siobhan Koch. I'm the Graduate Liaison Officer within the Faculty of Engineering here at McMaster University. Welcome to our W Booth Virtual Open House. This event is a great opportunity for you to explore the various course-based master's programs that are offered within our W Booth School of Engineering Practice and Technology. We hope that you'll use this time to explore our programs, to talk with faculty, engage with alumni, and get to know our current students. But most of all, to ask your questions. For now, we wanted to give you a really quick overview of each of our programs. So I'm going to pass this over to our incredible faculty members and they'll show more. Enjoy.
Hi, everyone. This is Zheng Gao, Associate Director of Graduate Studies and the Program Lead of System Technology at the W Booth School of Engineering Practice and Technology. Welcome to join our Grad Open House. The Booth School is an important educational unit at McMaster. We have been very proud to offer a few unique graduate programs, including engineering and public policy, engineering design, manufacturing engineering, and systems and technology programs. Each program has its unique and creative curriculum. For example, engineering and public policy is the only one of its kind in Canada, and this program has been well received by government and industrial sectors. Similarly, engineering design is another very unique program, which is focused on design thinking and human-centered design for applications in various industrial and healthcare sectors. For manufacturing engineering, in addition to the well-designed discrete manufacturing stream, biomanufacturing was also proudly present to meet the emergent industrial needs in this special domain. For system technology, it put more emphasis on the modern digital technologies, such as cyber-physical systems, AI and machine learning, big data, autonomous driving, and so on. So why MN programs at our school? Couple of reasons. So we list a few of them here. First of all, our school is housed with many dedicated faculty and staff and experienced educational practitioners and partners. Practice-based education is a guiding philosophy of our Booth School. Our students are offered with an engaging academic framework to get deeply involved in various approaches of practice-based education. Our educational goal is to equip students with a diverse skill set and mindset that enhance their potential for career advancement. The students' future success in their careers requires combined competencies such as technical proficiency, leadership, teamwork, and communication. Engaging students in community-based engineering practice, it is one of our successful approaches that students work on projects closely with faculty and community partners to address the real-world challenges. This approach facilitates experiential and transfer learning, enabling students to apply their knowledge effectively beyond the classroom. Now, let's talk about the master program of systems and technology. After a few years strategic preparation and development, in September 2020, the W Booth School of Engineering Practice and Technology received the first cohort of students in this program. The purpose of this program is to train high qualified personnel who can implement a variety of cyber-physical systems in various sectors of industrial, business, and government. MEST is missioned to cultivate HQP's diversified competencies that enable them to be practitioners and potential future leaders in the age of Industry 4.0. Systems and Technology program is unique in Canada, and it is one of the small number of programs across the world which focus on the Industrial 4.0. For the upcoming academic year, we will offer the following 3 streams: automation and smart system, automotive and digital manufacturing. There are 2 main pathways towards the degree. One option is 10 courses. Another option is 8 courses plus a project. So a project counts for 2 courses. The duration of study is flexible. You can choose to earn a graduate degree from 1 year to 2 years. Students in the program acquire competencies in areas essential for implementation of Industrial 4.0. For example, AI, machine learning, deep learning, smart systems, big data, sensors and image processing, autonomous driving, virtual reality, Internet of Things, cloud computing. We are expecting our students to gain the skill sets of these disruptive technologies and to be good leaders or engineering practitioners to make the world a better place. Various collaborations between our schools and our industrial and civic partners provide our students in system and technology with sufficient projects which utilize advanced technology to deliver a new generations of real-world solutions. Our students benefited from the practice-based learning environment that paves a foundation and creates a gateway for their future career. Every year, we received about 500 applications, which made this program very competitive. Among all streams that we are offering, automation and smart system received the highest number of applications. Popular courses such as machine learning and deep learning were created with 4 sections annually to meet the students' needs. To finish this stream with flying colors, good program skills, especially for Python programming, is necessary. Although the undergraduate background of most applicants of this stream is computer science or computing engineering, as long as you are confident about your coding skills, and as long as you are highly interested about the topics such as smart systems, AI, and data analytics, this stream could be one of your best options. Automotive is the second largest stream in our program. This stream offering the courses which are well balanced with good coverage of traditional automotive and vehicle subjects such as vehicle dynamics, internal combustion engines, vehicle design, to the landscape of new generation of vehicles with topics such as electrical powertrain, electrical drive vehicles, battery study for electrical vehicles. Students are also encouraged to take courses that enable autonomous driving. These courses include, but are not limited to, visual perception for autonomous vehicles, deep learning, sensors and actuators, natural language processing. We believe autonomous driving is the future of the auto industry. That's our motivation for keeping optimizing the course offerings of this stream to meet the ever-changing society needs. Of course, we also offer a bunch of traditional auto courses to consolidate the foundation of our students. Digital manufacturing provides a variety of courses that cover a broad area such as industrial networks, Internet of Things, and industrial Internet of Things, industrial automation, advanced robotics, additive manufacturing, virtual reality. We also offer software and programming relevant courses that are necessary for making our students ready for pursuing career success in advanced and integrated manufacturing, and smart factory. Students in our program have an impressive record for securing co-op positions in past years. We are very excited to see the excellence of our hardworking students. Our students push themselves really hard to pursue their dream. The successes are well reflected via the placement of co-ops and full-time job positions. We have full confidence of our students' continuing success, especially in areas of like machine learning, AI, cyber-physical system, data analytics, smart system, and electrical vehicles. The diversified competencies of students enable them to potentially become leaders and practitioners of state-of-the-art technology. As a potential future graduate student, you start to put yourself in the captain's position on journey of your future bright career. We believe that our Booth School is one of the best places that your future career could start from. Thank you so much for your time and interest.
Hello, everybody. My name is Fei Gen. I'm an associate professor in David Booth School of Engineering Practice and Technology. And I'm the program chair in biotechnology program and the biomanufacturing. It's my great opportunity to welcome you all. And I would like to provide some information about biomanufacturing program. First of all, I would like to explain what is biomanufacturing. Biomanufacturing is a really interdisciplinary field which really connects different sectors about the global biotechnology industry. It is a process of using living organisms, such as the cell culture, to produce important biologics, such as the antibodies, biopharmaceuticals, and also including the liquid biofuel industry, from one end to the high quality, high regulated biopharmaceutical industry, and also including the recently the booming field of cell therapy. The biomanufacturing processes includes the production of cell therapy, therapeutics products, the chemical production using fermentation, also energy production using biomass, as well as the enhancement of the food industry. In our program, we introduce a very good combination between technology and the business. So we provide a foundation in biomanufacturing, bioprocessing, biopharmaceutical industry. We introduce a lot of experiential learning experiences. So in this program, you are able to learn beyond the technology. You will gain the first-hand experience in global regulatory affairs, CGMP manufacturing, and you will gain the first-hand experience from our industrial collaborators. So some of the courses are delivered by our own faculty members, professors. There will be also some of the courses going to be delivered by the industrial leaders. So that's why you will learn a lot from the industrial knowledge before you graduate. And in fact, there's also some of the products we're running in the program are based on the raw product from the industry. Therefore, you're going to be ready for the real world before you graduate from our program. So there are a couple focuses in our curriculum, such as cell line development, regulatory compliance, quality assurance, as well as the business development. This program is relatively new. We started in January 2023, which is the first cohort. And in our program, This is the first master's program in biomanufacturing in Canada. So there are two options for part-time students and the full-time students. For full-time students, so there is a range from 12 months to 24 months of completion. For the part-time students, you will be looking at to 32 to 40 months completion. And we recognize there are a lot of demand, especially coming from the students or working professional who already have a regular job during the day, and they want to upgrade their degree during the evening and weekend hours. So that's why part-time option would be a very good fit in this case. There are two pathways to complete our program, which is 8 courses plus product, or 10 courses without product. So the options is really up to you, depending on the timeline of your completion, as well as whether you are really in demand, like product related experience. Where is the job opportunities? We just want to take an example, what's the kind of the situation in Ontario to share with you. Okay, so in 2020, there are 66,000 jobs in Ontario related to biomanufacturing. But in 2030, this number is going to increase to 85,000. So that's why you can see from the increase in the number of jobs, you'll see the booming industry of biomanufacturing. In the meantime, I want to share with you about the local ecosystem of biomanufacturing in Hamilton area. So there is a company, which is the Alumni Bio in Hamilton, very close to McMaster. And actually, it's a facility built in McMaster Innovation Park. Began the investment from a federal government from at $14 million. And this facility is going to be developed as a total cost of $580 million. And the entire value for this facility of this company is going to become the global leader of biomanufacturing of CAR T cells, which can be utilized to treat incurable disease like cancer, breast cancer, lung cancer, leukemia, myeloma. And over the next 7 years, over $2.2 billion will be spent by the federal government to invest in this discipline as well. Still focusing on the example, we're talking about the Alumni Bio facility in McMaster Innovation Park. There are 2 buildings. So the completion for one building, building B, will be completed by 2024, end of this year. And the building A, which is going to be completed by 2026. So for building B, they're aiming to recruit 500 full-time employees. And the building A, they're aiming to recruit 1,500 full-time employees. Therefore, this is the perfect timing for you guys to join this program, to gain the experience and get trained and take on these jobs for your future. Just want to utilize our Prime Minister's quote. So the scope for the program, for the talent development, is really trying to train many of you are suitable for the well-paying jobs, right? And you're going to become the main workforce of biomanufacturing in Canada. So as 2024, Moderna, which is a very reputed company, is going to build a facility in Ontario and Quebec to produce mRNA vaccines. And this facility is going to be completed by end of this year as well. And this facility is aiming to recruit 200 to 300 jobs. So there are 5 reasons to consider our program. First of all, it's the first graduate program in biomanufacturing in Canada. And there's booming opportunities in this field. There are many companies globally are creating their research and development center in Canada as we speak. Also, there are many industrial correlated products happening in this program. So that's why you will gain the industry experience before you graduate. And this discipline, this entire field is very multidisciplinary. So that's why no matter you are coming from engineering background, science background, health science background, computer science background, you will always gonna be able to find a good fit in this industry, and your future is very bright. And will be also a training module in our program to teach you with the regulation so that you are able to fit yourself in the biomanufacturing industry in the future. That's all the information I want to provide today. And here's my information. Feel free to reach out to me by email or give me a call should you have any question. Thank you very much.
Hi, I'm Robert Fleissig. I'm a professor in the W. Booth School of Engineering Practice and Technology at the Faculty of Engineering. I'm also the program lead for the Master of Engineering Design program. Our program, the Master of Engineering Design in Product Design, is a 16-month full-time program, which can be accelerated to 12 months, or a 40-month part-time program for domestic students only. Part of the full-time program also has an option of doing a co-op after the first 8-month classes. All our project work involves industry-connected or community-partnered design project, working in teams of 2 or 3 students with both a faculty member or more than one, sometimes supervisor, as well as a community partner and access to their end users and other stakeholders. To describe the program and what you're trying to learn can be best encapsulated by this rather famous quote from Dennis Lasden. Dennis Lasden was a British architect, and he said, "The designer's job is to give users and stakeholders not what they want, but what they never dreamed they wanted. And when they get it, they recognize it as something they wanted all along." This, to me, encapsulates the very core of our program. It is really imagining what that future design solution experience could be for our community partners and giving them something that they had themselves never imagined. But what they get is something that they really, really does meet the needs that they're looking for. So how do we accomplish that? Well, core to our program is the notion of design thinking. So design thinking, in my mind, is the ability to understand the needs of users and stakeholders better than they understand them themselves, so that you can then use that knowledge, that insight, and translate it into solutions that really make sense to them and that the end users will love. In our program, what we believe that great solutions, great designs, great technology begins with that deep understanding of human needs. It's co-designed with the stakeholders, so you work not just at the beginning of the project to get a problem, but throughout the project. And that the reimagined project, or that new design, comes from understanding and coming up with a better human experience for the stakeholders that are part of the project. So what are the kinds of projects we do? Well, we do projects in a number of technological areas, including cyber physical systems, which covers a wide range of technologies, including IoT, Internet of Things, digital reality technologies, augmented reality, as well as virtual reality, AI, machine learning, and mechanical and physical type products and systems. And these kinds of technologies are being widely now used in healthcare, in high-tech industries, in cities and infrastructure, and in manufacturing contexts. So each project and each student is expected to complete a project that is 8 months long, like I said before, done in teams of 2 or 3, working in tandem with faculty and industry, supported not only by their expertise, but also with their deep understanding of the people and contexts the design is intended to serve. In order to apply it for the program, we're looking for individuals with an undergraduate degree in science, technology, engineering, and mathematics. That does include degrees in industrial design and architecture as well, and at least a B- average in the last 10 technical courses of their undergraduate degree. So all this sort of learning and this interaction with community working on complex problems sends our students to all kinds of jobs. And this is just a short list of the kinds of work that our students have ended up doing as a result of the program. UX or user experience researcher, mechanical designer, consultant, product manager, and software developer. And we also have, I can think of another one yet, is a research coordinator for a local hospital. So we're looking for applicants who want to be challenged with work on wicked problems, want to be able to exercise their creative competencies, and are excited to co-design solutions with end users and stakeholders to create innovation through technology. I look forward to answering any questions you may have in the breakout session.
Hello, everyone. Welcome to the session, Master of Engineering in Manufacturing Engineering program. My name is Dr. Marjan Alavi, and I'm the chair of this program, also known as MIMI program. The Manufacturing Engineering program has two streams at the moment. One stream is called Discrete Manufacturing, which was the main and the older stream. This stream focuses on manufacturing processes with some aspect of automation. We also offer a new stream, which is Biomanufacturing Engineering. So that stream will be explained to you by my colleague, Dr. Fei Geng. Both streams have co-op options. During the co-op option, you will work for a Canadian firm and you will gain Canadian experience. The co-op is optional. If you like, you need to send your resume to a pool of candidates, and you will need to work with our co-op team to find a job, to find a co-op and enroll in that. I strongly recommend you to take either a co-op or a project. Projects are, however, considered as 2 units, and they will be performed during your studies inside the university. If you want to take a project, you need to pass only 8 courses and 2 project courses. By default, all of the students are considered course-based students. And if you want to enroll in a project, you need to reply to an email that will be sent to you by Salman Balwa and enroll in a project. The projects can be defined either by you, a faculty member, or by a community partners. The project will be a problem that exists in a firm or an idea, a research idea that someone has and needs your help to implement it or explore it or do some improvement to a process. By enrolling in the project, you may start your project at semester 2, and the project will run in 8 consequence months. You need to work with a team of maximum 3 students to perform a project. Some projects can be performed alone. During this program, you will get the competency in using statistical tools and advanced mathematical knowledge to optimize highly nonlinear manufacturing processes. You will pass a few courses and in discrete manufacturing, in manufacturing systems, and some other core courses. You need to pass mandatory number of core courses, and in addition to those courses, you will pass a few management courses and cross-disciplinary courses. And then you may select some courses that are outside the manufacturing engineering courses, which are multidisciplinary or cross-disciplinary, called cross-disciplinary courses. So you have the flexibility to choose your courses, and we expect the following course outline after finishing your program. including the ability to specify dimensional tolerance for outsourcing and control the quality of the incoming parts. Also, the capability to identify the operating boundaries of advanced manufacturing process. It is different from theory than experience, right? When you learn the theory, usually the boundaries are given to you. But when you go and work for an industry, you need to define the boundaries based on the application, the situations you are in, and you will experience this in practice by going to the co-op, by doing the projects, and also by learning the theory in the courses. Some of the courses also include projects. And we expect the students, the graduate students, to work in different fields, which are quite different. As you know, manufacturing includes multidisciplinary works. It can be manufacturing of electronic parts. It can be manufacturing of the discrete parts, let's say bolts and nuts, or some advanced machineries for aerospace. So at the end, the firm that you will work in, it can be very different. It can be from general manufacturing or design for manufacture, because not all the parts can be manufactured, right? So these are things that you will learn. Material process, automation and process control, and digital manufacturing. You also have the option to learn AI methods, which are very popular, and use AI in manufacturing. The courses that are taught are offered in different departments, including chemical engineering, material science and engineering, mechanical engineering, and some of the courses are offered at our school. We prefer you to enroll in the courses that are offered at our school, which starts with the code SEP or SEP. And then you can take other courses as well. The potential career sectors after graduating from the MIMI program includes engineering consulting firms, automotive or aerospace sectors, energy and nuclear industries, food and beverage sectors, oil and gas and mining, and heavy machinery equipment providers, advanced manufacturing industries, which are very broad, and process automation service, quality assurance and control sectors. We are also working with the railway system engineers to define new courses in that stream. And after passing those courses, as some elective courses, you will get the required knowledge to start working for those firms as well. These are new courses that upon approval would be sent to you, and you can enroll in those courses, and still are in the basic stages. So thank you very much for attending to my speech. And if you have any question, please feel free to ask your question during the breakout rooms and breakout sessions. Also, you can send me emails at alavis2@macmaster.ca with any question that you have. Thank you very much and have a wonderful rest of the day.
Good day. I'm Gail Kransberg, and I'd like to introduce you to the Masters of Engineering and Public Policy program. First of all, there's a need in society for this program because engineers and scientists can be really important advisors to decision makers in government, but also in the private sector. But usually they don't understand how public policy is formed or how it even works. So as engineers and scientists, you need more than just technical skills. You need a better understanding of the process of policy formation so that we can optimize economic, social, and ecological outcomes of our public policies for the benefit of society. But there is a disconnect between policymakers and scientists and engineers. So for example, a policymaker is going to ask, what's the value of this thing? Or what is a level of risk that's acceptable to society? Or why should we take action now? Because there's lots of resources we could put towards many different purposes, but why this purpose? On the other hand, engineers and scientists ask completely different kinds of questions, right? Like, how does the world work? What's the causal relationship between the phenomena we're observing? And so there's misunderstanding, there's frustration, even irritation when the policymaker turns to an engineer or scientist for advice. And really, it's very likely that that engineer will think the policymaker's question is a bit trivial, like, how good is the air today? Is it a 1 or a 5? Like, it's missing the point. Like, what's causing degraded air quality, for example? But it's also possible that an engineer or scientist answer to a policymaker who says, how's the air today? And then the engineer or scientist says, well, it depends on ozone and NOx and SOx. And the policymaker is going to think, you're really being ambiguous. You're being overly complicated. Just get to the point. So, introducing the Engineering and Public Policy program. We want to shape society into a sustainable future. So for this program, we have a vision that you will become world-class leaders who will be able to become policymakers, decision makers at a local level, municipal, provincial, state, national, even international levels. We've got some of our graduate students in the federal government, in the city of Hamilton, in international relations, in the UN, for example. So our graduates become leaders because they bring fact to the policymaker. In fact, is really fact-based policy is what it's all about. So we want you to be able to communicate to policymakers and decision makers what the sustainable 21st century solutions are in a way that talks the same language as a policymaker would speak. Your outcome then is an engineer or a scientist that's a holistic thinker, integrating environment, economics, social well-being, finding the balance between competing societal priorities. We hope you become inspired leaders in the policy arena, whether you're in government, in business, in non-government organizations, in industry. You could become the liaison between the policymaker and other sectors of society because you have the technical background, but you also understand all the different challenges that are associated with making policies that are effective. The major piece that leads you there, aside from the very critically designed courses that give you the tools, is your final thesis, the research project that you work on. And you can work on this research project independently or with a group of others who are like-minded, others who want to work on the same sets of problems. So we have formulated different questions that are at the interface of engineering, science, and public policy. So you might think about AI, for example, artificial intelligence and public policy. Are we infringing on people's rights? What about creativity? What about the artist? What about the songmaker? What about the inventor, the engineer? And then there's AI. So how do you balance policies around emerging issues, technical, complicated issues, climate change, carbon reduction, carbon capture and storage? What's the right thing to do? Carbon tax. What is the right thing to do? As an engineer or a scientist, how do you put your mind to that and also understand economic well-being, equity, equality? So we put an emphasis on learning by doing. We provide you opportunities to frame your question around solutions that are for questions that come to us in the school. Many of our outside partners come to the program and say, we need help. We need some policy advice on the climate emergency that Hamilton has just declared, or we need policy advice on autonomous vehicles and safety. So very different types of external partners come to us and say, we need help with you. And you as students will work with external partners to solve real world problems and design it in a way that is sophisticated, that reflects what the literature says, that has practical implementation ability, and that is your final thesis, and it gives you the ability to leave the school knowing that you can tackle complicated problems that are very real by practicing and doing it through the Master of Engineering and Public Policy program. So I thank you for your attention and look forward to seeing you in our program in the future.
Thank you for considering the W. Booth School of Engineering Practice and Technology within the Faculty of Engineering at McMaster University. My name is Salman Bawa.
And I'm Richard Allen. We work together in the community engagement function at our school. We're going to take 5 minutes or so and answer some frequently asked questions, all from the standpoint about how community engagement can serve you in your studies, in your transition to employment, and in your success in your career and in life.
Number one, what is community engagement and how does it help you in your studies? When we use the term community, we include industries, government, healthcare institutions, not-for-profits, associations, and even academia. Our community engagement process involves Richard and me having conversations with community partners, trying to understand their needs and carefully curating their challenges into potential projects for our faculty members and through them for our students.
And what's important to understand is that these challenges that we draw into our school from the community, they're real and they're open-ended, and they provide opportunities for you to learn both technical and managerial skills. It's also an opportunity for students to dive very deeply into complex challenges related to community engagement. And what happens is in these community engaged projects is you struggle very hard to listen really intently to what a challenge is and to come up with a proposed solution. So most importantly, it offers an authentic experience that mirrors real life problem solving.
Number two, what does community engagement at our school look like? We have established relationships with industries, government, healthcare institutions, not-for-profits, associations, and academia that provide us with challenges in the form of project descriptions, which are shared with the students when they join our programs. Students can then apply to these projects and are interviewed by the project faculty leads. Post-interview, faculty leads may offer the project to up to 3 students.
And once the teams accept the projects, they become their graduation requirement. So a degree requirement delivered through community engaged projects is what our actions are all about. We really emphasize that you work in teams, again, mirroring real life problem solving. And we really emphasize these opportunities to get out of the university grounds and actually visit the community partner within their workplace settings. And it's really important. Our expectations as students are that you listen very intently to the challenges proposed, that you reflect, and that you respond as a member of a team with a proposed solution. And most importantly, we hope that you learn and grow through community engaged project learning.
Number 3, why community engaged learning? History shows 3 key benefits of community engaged learning. Number 1, direct application of classroom theory. Number 2, growth in career readiness skills such as problem solving and communication. Number 3, relationship building with multiple stakeholders, including community partners, faculty members, and peers, who provide references and open doors to employment within the ecosystem of your project.
And what's really important is that through the process of working with your faculty supervisor and your community partner, you come up with a tangible deliverable. It could be a report, a design, a prototype. And what's really important in the process of creating the tangible deliverable is you develop a story, the story of hearing what a challenge is and coming up with a response And that story is really important as you transition to employment. So you can tell that story as evidence of your problem-solving skills and what you learned at university, and most importantly, what you can deliver for a prospective employer.
So number 4, Richard, can you share a story of a community engaged project?
Yes, Selma, one of the projects that we're really proud of at our school is several years ago, we had a challenge that came to us, and it had to do with industrial waste heat. Hamilton is an industrial center on a national scale. We have steel making processes in Hamilton and other heat intensive manufacturers. And the challenge was, is there an opportunity to harvest that excess residual heat and use it for district energy purposes? And we came together as a community with our school to deliver a report. And that report was crafted under the supervision of Dr. Chi Tang within our school. We also had 2 complementary students, one from the design program and one from the manufacturing program. And they worked in direct collaboration with Hamilton Community Enterprises and Hamilton Chamber of Commerce to deliver that report. And that report was very significant in showing the pathway forward to delivering the next stage of the process, which is a study that will show that actually harvesting that heat and using it for district energy is both technically feasible, but most importantly, Salman, that it's commercially viable. So that's a project that we're really proud of. Salman, what comes to mind for you when you think of a standout project?
Thank you so much, Richard, for sharing that example. And one example that comes to my mind is a project in which our systems and technology students were involved. This project was with St. Joseph's Healthcare Hamilton, one of the largest healthcare institutions in Hamilton. And we are fortunate to have a fabulous relationship with them. Dr. Michael Walsh, who works at St. Joe's, works in wound care, and he has several images of wounds of different categories. For example, a wound from a cut would be different from a wound if you bump into someplace. Now, why Dr. Michael Walsh is so concerned about wounds is because when wounds happen to people with chronic illnesses such as diabetes, managing that wounds becomes critical. And so the idea here was that, can we empower the consumers to take pictures of their wounds and over time use some sort of artificial intelligence algorithm that would show whether the wound is improving or deteriorating? So the students from Systems and Technology program worked with Dr. Wael Brahim, who is an expert in artificial intelligence, particularly when it comes to healthcare technologies. And under the supervision of Dr. Wael Brahim, the students from Systems and Technology worked directly with Dr. Michael Walsh and St. Joe's to come up with a proof of concept that allowed consumers to take pictures of their wounds, categorize those wounds, use an AI algorithm to figure out if the wound is improving over time or deteriorating, and if it is deteriorating, what kind of steps would the consumer need to take to improve their health. So this is a health and well-being project that involves artificial intelligence technology that came to mind, Richard. Moving on, number 5, how might you connect with us? Students, on your screen, you see our email addresses. So please feel free to connect with us, and we will be happy to address your questions.
Now, on behalf of Salman and myself and everyone at the W. Booth School, thank you for considering joining us. We wish you all the best as you make your decision, and we look forward to carrying on this conversation. Thank you.
Thank you for joining us for this presentation. We want to remind you that if you have any questions about any of the programs that you've heard about today, you are more than welcome to email us at enggrad@mcmaster.ca. That's grad@mcmaster.ca. But for the rest of this event, you can head on over to our expo section where you can interact with faculty, students, and alumni for each of our incredible programs. We will also have a session happening on co-op and the admissions process, so be sure to check those out. And again, thank you for being here, and we hope that you enjoy the rest of the event.